Alright class, so we are doing section 1.2 today. We are solving quadratic equations, and I have here listed the steps that are on your note pages. So there's more written words on the note pages. I just sort of did a short step-by-step to follow along as you're reading. Let's go ahead and start with question number 1. It says x squared plus 4x is equal to 0. Now, going through the steps 1 through 5, it is already equal to 0, so step 1 was done for us. We do need to factor this. So when I factor it, I'm going to say x times x plus 4 is equal to 0. And then, because two things are multiplying to make 0, then each of them could be 0 and make this true. This only works when it's equal to 0. That's why that first step is that. And then you solve. These are now linear equations that are easy to solve by isolating the value. And then you want to check. So we look at our original question. There's nothing in there like a fraction or anything else that would make these values not true. So all of these values are in the domain. Instead of doing multiple boxes, we are going to use that notation that we did last time. And let's go ahead and go to the next question. Number 2, we have x squared minus 9 is equal to 0. Once again, looking at step 1, it's already equal to 0. Let's go ahead and factor. I get x plus 3 and x minus 3 is equal to 0. We want to set each factor equal to 0, so I'm going to say x plus 3 is equal to 0, and x minus 3 is equal to 0. And then you solve this one by subtracting 3 from both sides. You end up with x is equal to negative 3. And this one we're going to, This one we're going to add 3 to both sides. And so I'll get x is equal to 3. And like I said, instead of boxing our answers as two separate answers, we're going to include all of our answers in the same set. And here we go, set notation. I have 2 values as my answer. You always want to check your work also. So you do it by plugging these values in, and then you're going to check to make sure it makes it true. Okay, we're continuing with question number 3. And make sure that you realize it changed the variables. It has v squared plus 7v plus 6 is equal to 0. Once again, step 1 is already done for us because it's equal to 0. So all we have to do is factor. And get v plus 6 and v plus 1. And then we're going to take each of those factors and make them equal to 0 themselves. And subtracting 6 from both sides over here gives me v is equal to negative 6. Subtracting 1 from both sides over here gives me v is equal to negative 1. I have two solutions, negative 6 and negative 1. Alright, so there would be your answer. Alright, and question 4 is already written for us on the board, and this is the first one where we actually have to do step 1, because it is written but is not set equal to 0. It's not written in regular quadratic format. So I'm going to have to subtract 40x from both sides. I'm going to end up with 25x squared minus 40x minus 16 is equal to 0. Now when you have something like this with such large numbers, you want to see if there's a GCF that you can factor out. In this case there isn't, but it's always a good check in case you can. I do see that 25 is a perfect square and 16 is a perfect square, so I think this might be a perfect square, but we'll try it. I think I'm just going to go ahead and try to factor it. If I say 5x and 5x, this multiplies by itself to make 25. If I say, that should have been a plus 16, huh? If I say 4 and 4, let's see if this works out. 5x times 4 is 20x, and another 20. That makes the 40 in the middle, and I used the correct sign. So great. So those are correct. Let's go ahead and say that is 5x minus 4 squared is equal to 0. Now that step was sort of unnecessary because we're just going to set our factors equal to 0. And those are the same factors. I'm going to add 4 to both sides. Left of 5x is equal to 4. Dividing both sides by 5 gives me a fraction as an answer. Now when there's one solution, I don't mind it when you box that solution. However, when there's two solutions, you don't want to box them because you might look at them as individual separate answers, and you have two answers over here. Over here, we only have one solution in our set notation. We're going to change methods right now. Instead of setting it equal to 0, we're going to use the square root property, and we're going to move the constant over to the other side. So, like we have here, instead of writing x squared minus 36 is equal to 0, we have x squared is equal to 36, moving that constant, the 36, over to the side where the 0 was supposed to be. And what this says is, if x squared is equal to p, and p is positive, so if x squared is equal to 36, and 36 is positive, then x will be equal to both the positive and the negative square root of 36. So it basically says x is equal to the positive square root of 36, and x is equal to the negative square root of 36. Another way of writing this would be plus or minus 6 as your two solutions. Over here, we have the same thing. If we take the square root of this side, it's going to be equal to the square root of that side. I'm going to say x plus 2 is equal to 1, and x plus 2 is equal to negative 1. However, this phrase on the left-hand side, even though it was a perfect square, does not isolate the variable. But it's very easy to do that at this step. So here I get x is equal to negative 1. And here I'm going to subtract 2 from both sides. And x is equal to negative 3. So I have two solutions, negative 1 and negative 3. We're going to continue using the square root method with number 7. However, you should look at the left-hand side and recognize that it's not a perfect square. It's not a term in parentheses with a square on the outside. So we do need to make it a perfect square. So the first thing we want to think about is the fact that this is our b term. We're going to divide that in half. So negative 6 divided by 2 is negative 3. And we're going to square that, and we're going to add that value to both sides. And so what I have here is x squared minus 6x plus 9 is equal to 22. And so I'm going to get x minus 3 squared is equal to 22. Now that I have this, what I'm going to do is square root the left-hand side. And I'm going to say that's equal to the positive and negative square root of the right-hand side. Now, if we know the square root, we should write it, but since 22 is not a perfect square, we just leave it in the radical. We simplify the radical if possible. But this one, it's not possible. So now I have x is equal to 3 plus or minus the square root of 22. We can do this completing the square method with almost every quadratic, although some of them are nicer than others. This one is not so nice, but we want to go over the method so that we can get good practice at it. So the first thing we want to do is move the c term over to the right hand side. I'm going to add 1 to both sides, and I end up with 2x squared minus 3x is equal to 1. I'm leaving myself space over here. The next thing we want to do is divide by that coefficient of 2. So I'm going to divide all the terms by 2. And so I end up with x squared minus 3 halves x is equal to 1/2. That's already not looking nice, but let's go ahead and do this. To divide 3/2 by 2, we also can think of it as multiplying by 1/2. So you're going to get 3/4. But after I divide in half, then I want to square it. So if I say, let's square it, then I end up with 9/16. And that's what I want to add to both sides. So I'm going to add 9/16. And I'm going to add 9/16. Yay for fractions, right? Well, this factors to be x minus 3/4 squared. Does that look familiar? That's this part right here. And then we have this, which is 1/2 plus 9/16, which is 8/16 plus 9/16. That's 17/16. Alright, let's clear our screen. And then we're going to take a square root of both sides. The square root of the left-hand side, since it's a perfect square, is just x minus 3/4. The square root of the other side is going to be plus or minus the square root of 17, and the square root of 16 is 4. So if I add 3/4 to both sides, it matches the other denominator. I will just get x is equal to 3 plus or minus the square root of 17, all of it over 4. Alright, so now we have the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac, all over 2a. It's written down here in the blue box. And we have a question. We want to make sure that we have it written in the correct format so that we can easily identify our A, our B, and our C as portions of the quadratic formula, quadratic equation. We're going to plug this into the formula. You're going to get x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 2 times 3 all over 2. Oops, I don't want to write a. 2a, which is 2 times 2. Alright, and then we're just going to simplify this each time, rewriting an equivalent equation. So you start off with x is equal to plus negative 5 plus or minus the square root of 25 minus 24 all over 4. If x is equal to negative 5 plus or minus the square root of 1. We're going to write each of these separately and get x is equal to negative 5 plus 1 and x is equal to negative 5 minus 1. So you're going to get negative 4 over 4, in other words, negative 1. And over here I'm going to get negative 6 over 4, and I'm going to reduce that. I'm going to get negative 3/2. So writing our two solutions in set notation, there's our answer. For question 10, we still want to use the quadratic formula, but we have to move everything over to the same side so that it's in the correct format. So we need to subtract the 1 from both sides and add the 2x to both sides. And so when we do that, we get 2x squared plus 2x minus 1 is equal to 0. So our a is 2, our b is 2, and our c is negative 1. So setting up the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And so what we have is negative 2 plus or minus the square root of 4 plus 8, make sure that you pay attention carefully to the signs, all over 4. Get x is equal to negative 2 plus or minus the square root of 12. Now you do want to simplify all your radicals. The square root of 12 can be broken down into the square root of 4 times 3. Pulling the 4 out of the radical sign will then give us negative 2 plus or minus 2 radical 3. I'm going to factor 2 out of everything, so I'm going to factor the 2 out. I'm left with negative 1 plus or minus radical 3. Factoring a 2 out of the bottom gives me a 2 left behind. So now I have negative 1 plus or minus radical 3 over 2. You can write it in set notation as negative 1 plus or minus the square root of 3 over 2, and put your braces around it. With a question like number 11, you can still use the quadratic formula, and it doesn't really matter which side you put your variables on. So I'm just going to put them on the right side for this question, just because I like my a term to be positive. Now, we have to pay close attention though, because we don't have 3 terms here. So our a is 4, our b is negative 5, and our c is 0. So when you plug that into our formula, you get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that negative b becomes a positive 5 because those negatives cancel out. And then we also get positive 25 minus 0 all over 8. You're going to go 5 plus or minus radical 25 over 8. So that becomes 5 plus or minus 5 over 8. Splitting those into 2 answers, because this doesn't have any radicals, we can actually simplify it. We're going to get 5 plus 5 over 8 and 5 minus 5 over 8. So we get 10 over 8, which simplifies to 5 over 4, and we get 0. So you have solutions, 5 over 4 and 0. You put both of them in the set notation. Alright, with number 12, we are going to go ahead and do the same quadratic formula. I once again have to move all the terms to one side. So we're going to end up with x squared plus x minus 1 is equal to 0. And so my a is 1, my b is 1, my c is negative 1. Once again, being very careful with our values and our coefficients and our positives and negatives. We have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And make sure that when you do that, you don't mix up your pluses, your minuses, and your multiplication symbols. And that's negative 4 and negative 1, so that turns into plus 4 over 2. Get x is equal to negative 1 plus or minus the square root of 5 over 2. And unlike the last problem, there's nothing I can do with this to simplify it. It's going to be like that. I could write it in a separate format, as separate fractions if I wanted to. So just for kicks, just to show something different, we have negative 1/2 plus or minus the square root of 5 over 2. splitting up the fraction because addition is in the numerator, you can do something like that. Now you have to be very careful. I didn't say this last time, but this negative here, it has to be in front of the 1, not in front of the fraction, right? Because that's how it's written in the formula. If you pull it outside the fraction, it means something different. So you do want to make sure that you have this formatted the right way. And there's our final answer. Alright, for our last problem, number 13 says, the area of a rectangular window is to be 306 square centimeters. So we know from this question that we have to draw a rectangle. So I always suggest drawing whatever figure it tells you to draw. And the area, it says, is 306 square centimeters. Now that gives us a hint of what we're going to do, because we do have an area formula. That area formula is always length times width. So we want to make sure we have some values of length and width to plug in. Now it does give us a hint also in the next sentence. It says if the length exceeds the width by 1 centimeter. We're going to take that sentence and turn it into an equation. So if the length is the width plus 1 centimeter. So we took all of that sentence and we translate it into math. Now we also have a formula here. Like I said, we have area is equal to length times width. I'm going to write it in initials. And now I'm going to take the values that I've gotten in the question, the 306, and this value given by this part of the sentence. I'm going to make substitutions in. So instead of area, I'm going to write 306. Instead of length, I'm going to write w plus 1. And then that's times w. And if I multiply everything out, I get w squared plus w. And then I'm subtracting 306 from both sides. I get w squared plus w minus 306. Here's our quadratic equation. Now you have multiple methods to solve it. I'm going to solve by factoring. And I used my calculator. I don't actually know what multiplies to make 306. But it turns out it is 18 and 17. And you have to make sure that you get the right values with the positives and negatives so that they add up to positive or plus w, 1w. And so if I take this, I get w plus 18 is equal to 0. W is negative 18. And w minus 17 is equal to 0. So I get w equals 17. Now which one of these could be a valid length? Definitely not the negative one. So I'm only going to keep the positive length. And so if my width is 17 centimeters, then also my length, based on this equation up here, would be 18 centimeters. And you do have to answer both, because the question says, what are the dimensions? So you can't just answer w equals. You have to find the width and the length. And make sure that every time you ask a word problem, you want to write down the formulas that you might know. Now I just want to recap this question. We have different portions of this word problem that help us figure out what to do. The word area gives us an idea that we want to use the area formula, and I'm going to put it right here. And then we had the 306, which was the value we were going to put in. And then we had the portion that I underlined in blue. And that became this formula over here. And when we combine them, that makes our nice equation right here. And so that's our wonderful equation that we're able to come up with that would be hard to come up with on its own, but by combining all the three different pieces, there you go, you have your quadratic equation, and we were able to solve this question.